Hello, my name is Ashish Kapoor and this is Mike Ziskowski, and we are both from Microsoft Research Redmond, and we are going to present a joint project we did together with Eric Horvitz on Windflow, basically trying to estimate the higher level winds using aircrafts as sensors. So essentially wind patterns are very important to do a lot of things. So for instance, if you know exactly what the winds are doing, you can very well predict how much time will an airplane take to go from point A to point B. And if you know the direction of the wind, you can actually exploit that in order to trim down the flight time, for instance. Also, the wind patterns are extremely important in doing any kind of weather modeling. If you don't really know what the winds are doing, it will be very hard to predict whether a storm is coming or whether a front is passing through. And finally, like one of the biggest challenges in path prediction of hurricanes or tornadoes is the fact that we don't really have very fine level of details about how the winds are acting in an area. So, the current state of the art is very manual intensive and very primitive. So basically, if you look at the map over here, the black triangles are the regions where NOAA, which is the atmospheric agency that provides all these forecasts for the continental United States, they provide some of the predictions for these black points only. And the way they do it is that they would release some weather balloons at maybe a couple of times a day. And as these weather balloons go up through the atmosphere, they'll record the data, transmit it back to the stations, and they'll do some number crunching on it. Again, very manually intensive, very sparse in time as well as in space. So our idea is that we can actually leverage a lot of information from the airplanes that are already flying in the air. So this is a snapshot of continental US during sometimes in the afternoon, and as you can see, there are thousands of aircrafts already in the air. So as they're traveling to the air at different locations, different altitudes, you can actually sense what are the kind of winds they are experiencing, and use that, harness all this information to come up with very fine, very refined predictions of the wind field over the continental US. So that's basically our contribution in this work. And the way we do this is very simple. A lot of information about this winds winds encountered by the aircraft can be inferred from the data in the web already. So when you go and search, for instance, for a flight status for Boston to Seattle, right? You can already get how long it's going to take and when is it going to arrive, right? If you look a little bit in detail, it's going to give you the ground speed, the ground velocity at which the aircraft is traveling. A little bit more detail, you can actually find out what the intention was, right? So looking at all this information, you can do a little bit of number crunching. You can do some machine learning techniques based on Gaussian processes in order to infer what is the headwind or tailwind an aircraft is encountering. And you have thousands of those, right? And you incorporate all of these in the model and come up with a much better, much denser, I would say, and much more accurate estimation of the wind, right? Why don't we look at a very specific example that we actually use to test our hypothesis whether this would give you a good model, and Mike Ziskowski is going to walk you through that.
Hi, thanks Ashish. I'm here to show and demonstrate some of the detailed experimentation validation that we did with the algorithms that Ashish was just talking about. And to do that, I'm going to use this application called Worldwide Telescope. This is a three-dimensional topographical display of the Earth, and where we can show data and flight paths and wind vectors and things like that. So hopefully this will be able to explain a little bit better detail about what we're talking about. So here on the screen, we're showing northwestern Washington. This is the Puget Sound region, and just kind of gives you an idea of where we are in the world. What I'm going to display here is a grid of yellow arrows. These arrows are essentially wind vectors that are determined off the NOAA weather prediction that Ashish was describing earlier. They launch these balloons in about 8 different locations about 3 times a day. And that generates a 3-dimensional grid of predicted wind direction and velocity in this area. Now, what we decided to do was pick a spot in eastern Washington, in Orondo, and test a balloon launch. And from that location, if we used these wind estimations to predict where that balloon would go when we launched it, this is the path that it would follow. And you can see it takes a bit of a northeasterly heading, ends up somewhere over here, kind of north of the Columbia River. Okay, by using the aircraft sensor network data, which is comprised of, I'm sorry, let me put this on so you can see a little bit better. All these little purple airplane icons are the aircraft that were flying around in the vicinity during this experiment. It was about a 2-hour window, and they're at various altitudes and locations. It's a non-uniform set of information, but a lot more detail than what we're getting, a lot more timely and a lot more in terms of spatial opportunities than what we were getting from the balloon information. So using these aircraft data, we can then create a new wind prediction grid. And if I zoom out a little bit, you'll see that the wind pattern here has a little bit more northerly prediction to it than the previous one, than the yellow arrows, which I'm showing here. It's a little hard to see, but I think maybe you can kind of pick that out. So by using this updated wind flow technique, then we're able to predict that the balloon would go here. And this is about 100 miles difference in variation from where one prediction versus the other would be. So quite a bit different. And you can see that the trajectory is relatively similar in profile, but definitely different in where it's going. And then we actually launched the balloon. And if I spin around here, I'm going to show you where it actually ended. And maybe you can catch that on the screen. But that little red flag indicates where the balloon landed. And you can see that it's much more close to the new wind flow prediction algorithms than what we were predicting with the industry standard wind forecast model.